afternoon and welcome to our MRG Talk Series 2023 webinar entitled RFID Technology and Application. I'm your moderator for this session, and it's a pleasure to introduce to you our esteemed speaker for today. So our speaker today is Dr. Syaiful Redzwan Muhammad Shah. He is born in Johor Bahru and living in Rompin, Pahang. He received his PhD degree specialization in microwave technology from Uppsala University in 2019. He is currently a RFID field engineer at Bug Services, Luxembourg. His current research interests include antenna design, electronic for RFID application, and smart sensing industry. As an accomplished RFID field engineer at Bug Services Luxembourg, our speaker has a profound understanding of RFID technology and its application. With no more delays, please join me in giving a warm virtual welcome to our speaker, Dr. Syaiful Redzwan Muhammad Shah. We are truly fortunate to have you here to share your expertise and insight with us today. So thank you, Dr. Syaiful Redzwan, for joining us. The virtual stage is now yours. And to our audience, if you have any questions, please don't hesitate to type them into the chat box. We will be addressing your question during the Q&A session. So you may start now, Dr. Syaiful Redzwan.
Yep. Thank you very much to the moderator, Dr. Badaria. So today I would like to present the talk for this MRG's talk series, which is I will present the RFID technologies and application. So my name is Syaiful Redzwan Muhammad Shah. I'm a RFID field engineer based in Luxembourg. Currently, I'm working with a Bug service, but we have a spin of company. We call it Shah, which is a focus on. So this is a agenda for today. We have a two-part of this talk. So I begin with the first. I introduce a little bit about the part of RFID technologies and the application, and then the second part is I try to introduce about the Joanio, which is currently I'm working with, and we try to get the what you call the identify and track the object. There is a number of forms of RFID technologies in the market, and the recognizable for the RFID is a low frequency, high frequency, and ultra high frequency. So to truly understand the technologies and its benefit, it's important to take a step back and look at the fundamental first. So the first principle of RFID is not new. It is first used during World War II. During the World War II, the British employed the RFID to track and identify the aircraft manufacturing system. And Mario Cardolo is an American inventor who received the first patent for this passive read-write RFID in 1973. In addition, in 1990, the first ultra-high frequency reader was developed. So why we use RFID? For RFID, as far as this object is within this range of the reader, the object is able to identify the reader and is able to send the feedback signal to the reader. With this use of this wireless technology, RFID tags do not need a direct line of sight to the reader, which brings some significant advantage compared to the barcode scanner, which is widely used in the industry today. The RFID tag can be embedded and hidden in the object, and several tags can be identified at the same time by a single reader. So by using this RFID technology, we can track your multiple objects, like I said, at the same time in the same situation. So what is inside this RFID system? There is a 4 component in this RFID technologies, which is there is a scanning antenna, a transceiver or RFID reader that's able to decode the information, the transponder or the RFID tag, and the computer database. The transponder is the RFID tag integrated with the microchip with the information coded onto the RF antenna. It can be passive or active tag. So the passive RFID tag does not use a battery or power source. So without needing a battery, these chips are able to last for a long period of time, even well past the need for the technology. And based on my experience, there's several chip manufacturers that state that the RFID technology can be last long up to 30 years. And an active RFID tag does use a battery, and they are typical larger device. And the reason active devices are preferable is that they can scan for much further away. And with a battery, they are able to produce their own signal and we transmit it from the further. And the last part is a computer database. This software can program the tag, manage the device and the data, remote monitoring, and hardware configuration. So there is a frequency operation in the RFID technologies. So we divided at 3 parts. For example, first part is low frequency, we call it LF, high frequency HF, or we call it NFC, near field communication. And the other part is a UHF, ultra high frequency. So first, for the first 2 parts, LF and HF, the coupling medium is an inductive coupling, where and the third part is a UHF, ultra high frequency. The coupling medium is a radiative. In these 3 parts, there is a different frequency operating, which is first the LF. They cover from 125 to 134 kilohertz. And the NFC or HF is 13.56 in world. For example, in Europe, they cover from 862 to 866 megahertz, but the operating for the UHF in global is from 860 to 960 megahertz. So ultra high frequency is a technology that is known as a range. It's extremely high range compared to the both first part LF and HF, and it's a good solution when you can try to track multiple products at one time, such as a large box full of product. There's a passing through the space or cabin full of inventory. So the use of this UHF technology spans many markets, include retail, healthcare, life science, pharmaceutical, anti-counterfeiting, transportation, and manufacturing. So the reach range is cover up to 30 meters and compile with the different standard of ISO. For example, in the UHF, they need to comply with the ISO 18,000, but for the NFC, they have two standards that we need to follow for ISO 14223A or B, and another one is ISO 15693. So it's a different type of application for different RFID technologies. Like I said, for the UHF, you can track the asset for the logistic. For the HF, you can use for the access control, transportation, or banking. And for the low frequency, we can use for the animal identification and product authorization. So the working principle for the LF and high frequency, basically the field which is generated by this RFID reader used to get coupling with the antenna of a RFID tag. And because this mutual coupling, the voltage will get induced across the coil of the RFID tag. And now the some portion of this voltage is getting rectified and used as a power supply for the IC as well as the memory element. So the IC is given some information such as like EPC, we call it electronic product code, read write capability, and it can be programmed, for example, to do web authentication or encryption. And for the UHF, like I mentioned, the coupling medium is a radiative coupling. In the case of this ultra high frequency, as a distance between the reader and the tag is up to 30 meters, the coupling between the reader and the coil will be the far field coupling, and the reader continuously sending the radio wave of this particular frequency toward the tags, and it responds, and the tag is sending a sufficient signal to the RFID reader. And now the sufficient amount of this signal which is being sent back to the RFID reader is known as the backscattered signal, and the intensity of the backscattered signal, this RFID tag does not activate until it comes into the range with the scanning antenna, and the tag will be notified by the antenna, and the information will be transferred. And this information is taken by the scanning antenna and the reader. What are RFID tags and how they do work? So basically, there's two components for this RFID tag. The first one is the antenna, which is a receive radio frequency wave. And the second part is the IC, integrated circuit, which is used for processing and storing the data, as well as modulating and demodulating the radio waves received by the antenna. RFID chip, and we have several chip manufacturers that we work with. For example, like we have this chip manufacturer from NXP, Infineon, ST Microelectronic, Impinj, SIC, and EM Microelectronic. And the application of the RFID. So there's several applications, like I mentioned before, you can use for the RFID application. For example, like access control. These RFID cards and the badges are reliable and secure. They can also store enough data for identify the personnel to grant the access to the door or to the access port. And the other things is logistic and supply chain application. This RFID tag used to easy to read when they are coming or they are moving from the logistic store. As a result, they are often used for the tracking vehicle and cargo container. And for the animal tracking, for the low frequency, they use a radio wave to easily penetrate in the animal body that contain a lot of water. It makes them useful for livestock identification and the tracking. And for another part is race timing. If you are familiar with the marathon or even the the event that require the race timing, the tags are placed on the back of the race number. You can easily find the antenna, and with the chip, it is allowed the administration to see where each participant it is, and also the tag can tell the exact time participant across the finishing line. So how to choose the best RFID tags? There's several important points that we need to consider before we choose the correct RFID tag. For example, the price of the tag. The cost of the tag depends on the construction and the volume needed. For example, here in Europe, the inlay tag costs around 0.09 to 2 euros, while the hard tags cost between 1 to 20 euros. It use if you buy this large volume, you will get a more cheaper or better price. And the second part is the environmental factor. Is it tax resistant to high temperature, water, and chemical? So it is always evaluate your environment and only shop or only buy or only order the RFID tag for a tag that you can work optimally under the prevailing condition. And another part to be considered is a method of attachment. Which attachment technique that you want to use with your RFID? Either you put on the surface, or you bending, or you put inside the container. So it is adhesive, rivet, or epoxy. You need to check that the tag you use can be affixed using your what currently I'm doing in the VictorBug service. So VictorBug service is a part of the post Luxembourg, is the biggest company in this Luxembourg. There's almost 4,700 employee for last year 2022, and they have a turnover about 891 million. And for the VictorBug service in 2022, there is 170 employee, and the turnover is around 31 million. And we have several part of the among the post group. We work together with the VictorBug service with another company for the computer service, IT development, and also the logistic purpose. And we have around the world for this company, for VictorBug service. Our headquarters is in the Luxembourg, which is we have 3 office here in Luxembourg. For example, in production site, we have that I'm working with is in the central of this Luxembourg, and we have office in Hong Kong, Singapore, Sydney, and Birmingham. So thanks to this organization, VictorBug service is able to provide the printing and mailing service to the customer based in Europe, Singapore, like I mentioned, in Asia, and also the Australia, at the best price or quality with the same standard of the security and quality of the printing process. So our approach, which we try to combine the innovation technologies with the first-class customer service across a different time zone and global operation, make our service offering totally unique. So coming back to the Joanio, we produce the paper-based inlay for electronic application with tailor printing in the Luxembourg. our approach is eco-friendly antenna and inlays. So VictorBug Service launched this spin-off company, we call it Joanio, to offer this NFC, RFID, and IoT antenna and inlay for the smart IoT device. We preferable to print on the recycled substrate using an eco-friendly production process. We have a different chip manufacturer we work with, like I explained before, NXP, Infineon, ST Microelectronic. And we use multiple applications, for example, in pharmaceutical, food and beverage, logistic, secure document and retail. And we offer this rapid prototype service for this designing the RFID inlays. And we have this pick and place capability to put the component electronic up to 80 component per time, and we can print the inlay with the multiple substrate. So we have currently 1,000 square meter ISO 7 clean room production facilities, and we follow this standard for different frequency operation for RFID. For example, UHF, we use a standard ISO 18,000. For the NFC, we have two standard ISO 14 and ISO 15. And we have also worked with the lower power wireless technologies such as LoRaWAN. So how does Joanio produce? First, we have a customer coming to us, try to customize the inlay. So we have discussion, we have this meeting, how to define the requirement, and also try to give some idea depending on the target application. And we try to define the best suitable substrate and the chip for this customer. And we perform this parametric study and optimize by using this software CST. And for example, like what I currently doing is for the UHF RFID, we try to develop the RFID integrated in the test blood tube. So we work with the laboratory here in Luxembourg to track the blood sample from the patient. And I'm designing this UHF to put on the each test tube to be able to track each patient name and also type of the blood and where they taken this blood sample. So I did a parametric study with a simulation. We tried to optimize where to put this inlay and where this condition can be optimized. For example, the bending radius, and also try to fine tune the frequency resonance based on the IC chip. And we designed this tailor inlays based on this co-development with the customer. And we try to find a sustainable and effective product matching with the target application. And our inlay are configured to fit all technologies from the start, lower frequency to ultra high frequency. And we do prototype based on the selection of the conductive ink. For example, we use a silver ink and copper ink for the prototype. And we configure the screen printing parameter based on this 3D printing machine. And we produce the multiple sample for the testing and validation. And we try to compare the simulation and the prototyping result with the measurement. And we discuss with this client about how to optimize with the real condition. So for example, like the design of UHF that I explained before using this CST, I print this the antenna on this prototype machine, and we do some proof of concept. We try to see how much and we can see that in this particular proof of concept, we can achieve up to 4 meter when we read this bulky UHF reading antenna. And we still have different position that we need to take care about doing some measurement. For example, from rotation of this test tube, we try to do some rotation from 0 to 360 degree, and we see clearly different in between this reading performance when we measured this all this bulky tube antenna. And we print after we discuss about this proof of concept, and the client were happy with that. So we have this opportunity to produce the UHF inlay based on the screen printing. We have several dimensions that we're capable to do it in this clean room, from the sheet to sheet or A4 size machine. And we have some one of a machine we can produce for the roll to roll production up to 330 millimeter width of this paper, and with the variable quantities of this inlay. So for in case for this test tube, we have what do you call it order from this client up to 100K. So we need to produce a big roll of this quantity on this production. So our eco-friendly industrial is additive printing process, which is we use no water, no vacuum, and we try to generating the minimum of waste when we produce this big quantity. So this machine is having 3 layers of printing process. We use a curing process with the NIR, near infrared. So the challenge of this application for this blood tube sample using the UHF RFID, the healthcare medical try to analyze this laboratory customer require the new RFID labeling solution for the test tube application. It needs to be accurate, efficient, above all, ensure patient confidentiality. So Joanio solution try to work with this laboratory to design and print the UHF inlay on the paper substrate. And we try to do very limited waste production for the ink. And the inlay we use to ensure the traceability, security, and web authentication for their patient data. And this is a unique feature, include the triple data redundancy, thanks to the RFID, barcode, or OEM label. And the second part is a security and a confidentiality guarantee for using this untraceable feature and the password protection. And the last part is a eco-friendly production. We print on this SC certified paper substrate that can be easily recyclable. The second part of the user case is about the revitalizing the musical experience. So we develop, we have this customer that have challenged us to produce this NFC. They say like this day music is often sold as a digital platform, and how can this NFC can sell the song and audio record in their physical product. So Joiner's solution, we work with this company to revive this music cassette NFC tag, and we produce a visual striking NFC antenna on a paper. And when customer activate the tag and tape on this cassette tab NFC reader, to the phone, the antenna immediately enabled to download or to hear the audio recording. It is a unique feature for this antenna include a physical package that make digital content more valuable and enhance the customer experience. The second part is this NFC. They have a temporal loop to design these facilities to protect this copyright, which is a benefit for the musician and the artist. And we try to validate the purchase for this customer, and we custom the content based on the management requirement. And of course, we produce this eco-friendly production, and we use this FSC certified paper substrate can be easily recyclable. So the result is that this client now has a unique product they can sell to the customer, and they have a wider audience, for example, in orchestra and also for this music film event. And this copyright for this protection for the artist can be improved. The third part or third use case that we try to develop for this NFC, we try to enhance customer trust and experience. We use this RFID for tracking of the product. So, for example, like in this case of the bottle of this medicine, they are often sealed with a plastic tank. Either twist, stretch, or need to be perforated. Have this protection. So Joanio solution produce this paper substrate and also thanks to the interaction with the tech, you will also know when and where is they happen during the tempered loop is break. So you can easily track the problem back to the source. And the result for this use case, they reduce the waste, money saved, and problem averted. And you have also enforced the trust with the customer as well as enhancing their experience of the product. And the paper-based substrate with the temper loop can be used in any industry that has a strict quality control and health regulation. And you can also use for this food, for the pharmaceutical, medicine, and over-the-counter medication, vitamin, hygiene product, cosmetic, and many more. So all this eco-friendly tech is made in Luxembourg, from the design to the distribution, and we deliver worldwide. In summary, for this RFID technology, it is in many applications. For example, in contactless payment transaction, asset tracking, real-time location system, access control, retail, marketing, and many more. And for Joanio, we try to get an approach to bring a sustainable and innovative approach to produce RFID and NFC transponder to the customer. So our main point is we try to produce the eco-friendly antenna for this RFID to minimize the environmental impact. And we try to have highly flexible pick and place on this SMT component with the sheet-to-sheet or row-to-row printing. And we try to have some approach with a recyclable substrate at the first choice with the FSC paper substrate that can be recycled. So before I end my talk, I will try to play some video about how the feedback from the customer of one of the use case. Wait, I try to play the video. I don't know if can you see this video?
No, we cannot see the video.
Wait, I try to share again the try to share again the video. Is that okay here? You can see the video. So yep, that's my last presentation for today. Thank you very much for your attention.
Thank you to Dr. Syaiful Redzwan for sharing your expertise and shedding light on RFID technology and its application. Now, I open to the audience to ask questions to our speaker. Is there any questions from the audience? You can turn on your mic. Okay, so if there is no question, maybe I can ask one question from my side. Dr. Syaiful Redzwan, you said the RFID tag is also applicable for medical application, right? So,
Yeah.
is there any RFID tag that is already implanted for tracing, like tracing a person?
Yeah, it's a part of this research and development right now on this application, which is we try to work with this chip manufacturer for using this RFID tag to produce to monitor the what you call disease for the what do you call it shit, I forgot this name. Lymph edema and also the fat channel. So there's a chip that can be tuned for this frequency of UHF. It's very small, but it's limit to this the power that we can transmit. For example, in Europe, we have this strict power that need to be followed 4 watt per kilo per kg, which is a SAR compliance. So now we have this kind of proof of concept, but still in development with some hospital here in Luxembourg for this RFID tag that can monitor this disease.
Okay, so meaning that RFID tag also can be implanted under the skin?
It can be implanted, but it is up to 3 millimeter only in the epidermal surface, or in the
Okay.
surface of skin, not inside the body.
Okay, so
Because
on the skin. That's the
yes, only
limitation.
the is a limitation, because the penetration of this RFID inlay is not going inside because due to the water content in the body. So it's a strict limitation for this application.
Okay, okay. Thank you. So we have
Yeah.
another question in the chat box from Dr. Mama Haris. He asks, is RFID reader capable to read multi-text simultaneously?
For the there's a two part. For example, like NFC, we cannot read in the multiple reader because this is coupling medium. Like I presented before, we need to take one by one. But if you have this what you call capability to deliver to the customer with the roll-to-roll machine, we have this machine QA machine that can capable to read each tag during this roll process. So to answer your question, for the NFC, we cannot read in a multiple tag in the same time, but we can read each tag in the roll form. But different in the UHF, we have this capability to read in bulk reading. We have, for example, in the case of this test tube, we able to read 100 tube blood for different application for this RFID tag.
Okay, thank you, Dr. Redzwan. So is there any question before we end up the session? Okay, so if there is no further question, before we end our session, I would like to take a group photo. So I invite you to turn on your cameras for a quick photo session. Can everyone join this session? Can turn on their cameras? Okay, thank you. You guys so sporting. Okay, so thank you once again to Dr. Redzwan for your willingness to give the seminar from MRG. Even though you are far away from Malaysia, it's like 6 hours difference, right? So he
Yeah,
said,
I think now it's morning.
yeah, it's 7 in the morning. So we really appreciate your kindness and also willingness to share your expertise in RFID technology. So
Thank you very much for inviting me.
yeah, so we are also I personally also gaining valuable insight into RFID application, and I know that RFID application can be also used in many potential applications. So, and I also would like to thanks to our audience for participating in our MRG seminar. Okay, thank you so much. And if you have any remaining questions related to RFID, so you can directly contact our speaker. And also feel free to connect with us in our Facebook Microwave Research Group. So this recording link will be shared through our Facebook and also in our YouTube link in in YouTube Microwave Research Group. So thank you very much for your participation today. So see you in our next MRG seminar 2023 in coming September. So we will announce later. Thank you. Assalamualaikum.